Hello there, AP Environmental Science class. Welcome to Chapter 19, Air Pollution and Ozone Depletion. We are going to be dealing with a two-part lecture here. Once again, we're talking about 63 slides, so I will break it into two parts, with part one beginning right now. So once again, Chapter 19, Air Pollution and Ozone Depletion. Here we go. Starting off with a core case study out of Los Angeles. Back in the 1950s, the Los Angeles air was amongst the dirtiest in the world. This is because of industrial emissions along with motor vehicle emissions. In addition, if you know Los Angeles, there's kind of a ring of mountains around it with an opening to the Pacific Ocean, and that actually leads to a lot of temperature inversions, which actually cause pollutants to be situated closer to the ground. We'll talk a little bit more about inversions as we go through this lecture. But because of that, public protest over the smog in the 1950s and 1960s actually led to Congress passing the Clean Air Act in 1970. The Clean Air Act mandated pollution control measures, and the result was a dramatic improvement in air quality. So we talk a lot about negatives here in this class, but this is a success story, right? The Clean Air Act was put into effect, and the air got much cleaner. So bravo to that. Lowest pollution levels we have now, revisiting the air pollution since 1999. The largest sources of pollution are the ports of Los Angeles and Long Beach because most ships burn diesel fuel. And again, pollution is trapped by mountain ranges, which then builds up during those thermal inversions that I just spoke about. But again, this is a success story. While the air is still kind of dirty sometimes in Los Angeles, especially when they get these inversions to set up, definitely much better than it was back in the 50s and 60s. So when we talk about air pollution, we need to learn about the atmosphere, Earth's atmosphere, because that's obviously where the air is that is being polluted. So innermost layers of Earth's atmosphere, the troposphere is the lowest level of Earth's atmosphere. That's the level that we're dealing with here at the surface. And this supports life. Between the troposphere and the stratosphere is something known as the tropopause. Then we get to the stratosphere, and what's important about the stratosphere, which is the next layer above the troposphere, is that the stratosphere contains the ozone layer, which protects us from cancer-causing ultraviolet radiation. And we'll talk more about the ozone layer a little bit later in this lecture. So what is an atmosphere? An atmosphere, just some terms for you here, is a thin blanket of gases that surrounds the Earth or any planet or moon for that matter. Density is the number of gas molecules per unit of air volume, and the density of air decreases with higher altitude. This should bring some Earth science memories back to you. But again, as you go up in the sky, obviously, the air pressure decreases because there's less air up there. The density of air is less, and so it decreases with higher altitude. What is pressure? Atmospheric pressure is the force per unit area of a column of air, or basically how much air is pushing down on you. And again, that decreases with height because you got less air up top. The higher up you go, the less air pushing down on you, and therefore your pressure is less. All right, so understand these terms. This is something you may remember from your Earth science reference table, but basically it's showing you the four layers of the Earth's atmosphere: the troposphere, stratosphere, mesosphere, and thermosphere. You'll notice the temperature decreases in the troposphere, but increases in the stratosphere because of that ozone, which actually traps that ultraviolet radiation, actually making the temperature warmer. So believe it or not, temperature increases in the stratosphere, then decreases in the mesosphere, and then increases a bit in the thermosphere. You'll notice pressure decreases as you go up in height, right? So the greatest pressure, air pressure, is right near the surface where most of the air is pushing down on us. As you go higher up in the sky, obviously there's less air pushing down on you, and so your air pressure gets less. All right, so when we talk about air pollution, we need to talk about the movement of chemicals, the air movement, and the movement of those chemicals in the troposphere, which obviously affects Earth's weather and climate. So the troposphere is where 75 to 80% of Earth's air mass is located. Again, the troposphere, the lowest layer of the atmosphere where we're living. It's closest to the Earth's surface, and the composition of gases in the troposphere: 78% nitrogen, 21% is oxygen, and then the remaining is a bunch of composition for the remaining 0.1, the remaining 1%, there is a bunch of different gases in the atmosphere. Rising and falling air currents and greenhouse gases play a major role in weather and climate. So what are our greenhouse gases? Water, carbon dioxide, methane, and nitrous oxide. Okay. Now you're probably saying to yourself, water? Water is a greenhouse gas. Believe it or not, water is the most potent greenhouse gas, meaning water traps the most outgoing infrared radiation compared to carbon dioxide, methane, and nitrous oxide. Why don't we hear, though, when we talk about global warming, water vapor? Because water vapor is not anthropomorphic, meaning we as humans aren't adding additional water vapor into the air, right? The amount of water on the planet is the amount of water on the planet. Anthropomorphic, that means created by humans, that's the carbon dioxide, the methane, and the nitrous oxide that comes from air pollution or the pollutants that we're putting into the air. So that's why when you hear greenhouse gases, you're probably more used to the latter three here. But believe it or not, water is the most potent greenhouse gas. Again, it's just not anthropomorphic, meaning we as human beings don't create it. So there's nothing you can really do about that. It's the other three that we need to talk about, and we'll do more about that in chapter 20 coming up next. So stratosphere, again, we're heading now just above the thermosphere to the stratosphere, and that is considered our global sunscreen because that's where the ozone is that protects us from UV radiation from the sun. So the stratosphere, 17 to 48 kilometers above Earth's surface, similar composition to the troposphere, except you have a lower volume of water vapor and a higher concentration of ozone. And what is ozone? Ozone is 3 oxygen molecules put together. All right. So what is so important about the ozone layer? Well, it filters 95% of the harmful ultraviolet radiation from the sun. UV radiation is what causes cancer, and this allows life to exist on land. If we did not have an ozone layer, there would be no life on land on this planet because the UV radiation from the sun, any cells that try to develop that ultraviolet radiation would destroy or mutate those cells, and therefore killing any organisms that may have migrated onto the land. So thank you, ozone layer, because that has allowed life to exist on land and to evolve on land. All right, so what are the major outdoor air pollution problems? So we talked about now the atmosphere. And now we have to talk about the pollution that, unfortunately, we continue to pump into the atmosphere. So a couple of terms to understand. Number one is industrial smog. Industrial smog is caused primarily by burning coal. The second type of smog is called photochemical smog. Photochemical smog is caused by emissions from motor vehicles, industrial facilities, and power plants. And what we'll talk about in a little bit, there has to be sunlight added into the equation to produce photon, sun, chemical smog. And we'll talk more about that coming up. So air pollution is the presence of chemicals in the atmosphere. That's what we're talking about. That's the definition of air pollution. But those concentrations need to be high enough to be able to harm organisms, ecosystems, human-made materials, or to alter climate. Okay, so if you have chemicals in the atmosphere that aren't doing harming organisms or ecosystems, then we really don't call that air pollution, right? The concentration has to be high enough to start affecting things. There are natural sources of air pollution: windblown dust, pollutants from wildfires or volcanic eruptions, and volatile organics released by plants. But as you can probably imagine, the natural sources are a lot smaller than the human sources. So human sources include, again, mostly in industrialized and urban areas. We have stationary sources like power plants and industrial facilities, and we have mobile sources of air pollution, which are mainly our motor vehicles, our cars and trucks that we drive around. There are 2 types of pollutants. First are primary pollutants. These are pollutants that are emitted directly into the air. We then have something called secondary pollutants. And again, we'll talk more about all this in a bit more detail as we go through parts 1 and 2 of this lecture. Secondary pollutants are formed from chemical reactions of the primary pollutants. So secondary pollutants, we throw primary pollutants in the air, then they react together, and then they produce something known as secondary pollutants. And again, we'll talk more about that here. So again, this is human impacts of air pollution, again, from mobile or stationary sources. So first we'll look at the stationary source, Again, some kind of, or again, we have a natural source like a volcanic eruption. We have a stationary source, a human source like a power plant, an industrial plant, and then we have a mobile human source, which is basically, our cars and our trucks. So what happens is we put these chemicals directly into the air as primary pollutants. So, for instance, carbon monoxide, carbon dioxide, right? Nitrous oxide, et cetera, are these primary pollutants. But then secondary pollutants like sulfuric acid, for instance, okay, or maybe ozone, right? Ozone is actually a pollutant when it's at the surface. We'll talk about that in a little bit. Come when these primary pollutants react with the atmosphere to actually form secondary pollutants. So we're actually doing a double damage here when we put primary pollutants into the air, because not only are the primary pollutants harming organisms, harming ecosystems, but then they are combining with other gases in the atmosphere to produce secondary pollutants that, again, are going to harm in ecosystems and harm organisms. So again, understand we have these human and natural sources that are producing primary pollutants and producing then secondary pollutants as those primary pollutants react with other gases in the atmosphere. So again, this is what I like to call a lose-lose situation, as again, we're not only creating pollutants, but then those pollutants are producing more pollutants, et cetera, et cetera. So air pollution obviously has harmful effects. Air pollutants flow north to form Arctic haze in something known as the grasshopper effect, where pollutants tend to flow from areas of warmer weather to areas of colder weather. So not only near the poles, causing this Arctic haze, but sometimes up in mountains, you get more pollution because of this grasshopper effect. Since the 1970s, outdoor air quality has improved in the more developed countries. Again, not only did the U.S. Put into effect that Clean Air Act, but other developed countries have put in other laws in their countries to help with air pollution. However, fine particles can still get lodged in the lungs. What are fine particles? Again, just particles of pollution floating around. These fine particles are contributing factors to cancer, asthma, heart attacks, and stroke. Outdoor air pollution kills 1.4 million people in China per year, and over 500,000 people in India per year. So obviously, it still is a huge problem, especially in nations that maybe don't have stringent laws or maybe are just underdeveloped nations. Air pollution is still a major problem. Now, there are two types of air pollution, indoor and outdoor. We're going to first talk about outdoor air pollution, and then in part 2 of this lecture, we will look at indoor air pollution a little bit. So what are some major outdoor air pollutants? Well, your carbon oxides, right? Your carbon monoxide, CO, and carbon dioxide, CO2. We also have those nitrogen oxides and nitric acid, right? This creates acid deposition, and they play a role in photochemical smog. What is acid deposition? That is acid rain. We also have sulfur dioxide and sulfuric acid, which reduce visibility and can aggravate breathing problems, all right? So these are the major outdoor air pollutants that we can get. We also get particulates, which are basically just suspended particulate matter, right? Those fine particles in the air. We have ozone, which can cause coughing and breathing problems. Again, in the stratosphere, we love ozone because it protects us from ultraviolet radiation. But at the surface, ozone is a pollutant. All right. It's actually a secondary pollutant at the surface, which can cause coughing and breathing problems. And we have something called VOCs, or volatile organic compounds, like methane, benzene, dry cleaning fluids, and various components of gasoline and plastics, right? We release these VOCs, or these volatile organic compounds, into the air, and that is a form of air pollution as well. So again, we have these chemical reactions that do form some of our major air pollutants. So carbon monoxide, 2 carbon plus an oxygen diatomic molecule. Most times oxygen, it comes 2 in nature, right? Not 3 like ozone, can produce 2 molecules of carbon monoxide. There's your carbon dioxide. There's your nitric acid, right? NO is nitric acid, nitric dioxide, NO2, sulfur dioxide, SO2. So definitely understand these major air pollutants. Please do understand the chemical symbol for these major air pollutants and kind of how they are produced, all right? You will need to have a general knowledge of that for my test and for the AP exam as well. So here's a picture of how some sulfuric acid has done damage. This is a statue in Rome, Italy. And what you'll notice here is the nose and forehead have actually been restored. So in this area here, it's been restored. But all of this here, this dark black you see, that is because of sulfuric acid in the atmosphere, pollution, acting on that statue over years and years and actually degrading the statue there. So down in New York City, you'll see this on many old statues and old buildings. And obviously, if you go overseas, you'll see it as well. So if you are out and about, take a look at this. And if you notice it, you'll be able to tell your traveling companions what that is. That is air pollution that has unfortunately created issues for that statue. Lead is another highly toxic pollutant that can end up in the atmosphere as air pollution. So lead, this is a core case study, not as big of a deal now. When I was your age, lead was a huge issue. We've kind of dealt with lead a little bit, but still something to mention. Lead is in the air, water, soil, plants, and animals. It does not break down in the environment. It impacts human health and the environment. Children are most vulnerable, can cause death, brain damage, and paralysis if you do get lead poisoning. Lead exposure for adults and children, again, working in those e-waste recycling dump sites that we spoke about in a previous unit, right? Trying to dig through that electronic waste. And unfortunately, children and adults are being exposed to lead. And then they're letting any lead potentially get into the atmosphere as well when they go into these dumps and try to collect this electronic waste for recycling so that they can make some money for their family. So one of our favorite charts here, lead poisoning, prevention on left side, control on the right. So replace lead pipes, plumbing fixtures containing lead, phase out leaded gasoline worldwide, which pretty much has happened. Again, here we just use unleaded gasoline. Back in the 70s and 60s, they had something called leaded gasoline, believe it or not. But that is pretty much here in this country, 100% phased out. You want to phase out that waste incineration, right? We spoke about that in a previous unit, how when you burn your waste, you're releasing those toxic chemicals into the air. One of those toxic chemicals is lead. Ban the use of lead in computers and TV monitors so we don't have to worry about it in electronic waste dumps. Ban lead glazing for ceramic ware, and wash fresh fruits and vegetables. Control, remove leaded paint, lead dust from older houses and apartments. That was the big push when I was your age, because the paint back in the 60s and 70s was lead paint. So back in the 80s and 90s, they realized this and started taking the lead paint out or painting over it with paint that didn't have lead in it. Sharply reduce your lead emissions from incinerators. Remove the lead from TV sets and computer monitors. Right, test blood for lead by age 1, and test for lead in existing ceramic ware used to serve food. All right. So again, you understand when we get these charts, just understand a little bit on the left side and a little bit on the right side. Okay. Going back to air pollutants from burning things. All right, we're going to talk about coal and how burning coal produces industrial smog. So we spoke about coal when we looked at non-renewable resources, and one thing we talked about was how dirty coal is to burn, right? Well, now we're actually going to talk about that. The chemical composition of industrial smog, and again, burning coal produces that industrial smog, is sulfur dioxide, sulfuric acid, and suspended solid particles, right? None of those are good for the environment and for the atmosphere. The combustion of coal and oil also forms carbon monoxide, carbon dioxide, and soot, right? Soot are just, again, particles that are out there that you can breathe in. And unfortunately, industrial smog is common in industrialized urban areas like China, parts of the Ukraine deal with this. Beijing air quality is among the world's worst, right, out in China there. And this is because of that industrial smog. So this kind of shows it here. This is a greatly simplified version, however, of how these pollutants are combined and formed when coal is burned to produce industrial smog. So you'll notice in coal, we have carbon and we have sulfur. The carbon in coal and oil is obviously, when it's burned, produces carbon monoxide, carbon dioxide, and that soot. When you burn when you burn coal, the sulfur is released and then forms sulfur dioxide. Maybe oxygen is combined to form sulfur trioxide or another secondary pollutant, sulfuric acid, right? Some ammonia that may be in the atmosphere then forms with that to form ammonium sulfate. So again, you have all these chemicals that basically, or all this air pollution that basically comes just from releasing carbon and sulfur from burning that coal. And then this creates the industrial smog that is a huge issue, not only for organisms, but for ecosystems as well. That's also what we're looking at when we're looking at here. This is your coming from basically the pipe of a car here, right? This is your nitrogen in fossil fuels, combines with oxygen to produce nitric oxide. Or nitrogen dioxide. Then you get some ultraviolet radiation from the sun and water vapor, and now you get nitric oxide and you get some ozone to actually form, right? So again, these are some of those secondary pollutants that can form by just releasing nitrogen from the fossil fuel, from that gasoline into the air. All these different pollutants then have a chance to form because of their interaction with other gases and molecules in the atmosphere. So again, this industrial smog, burning coal, so dirty, and it's why we need to be moving away from these coal-powered plants. Talking a little bit more about cars, right? When you add sunlight, now you get that photochemical smog that I talked about. Photochemical smog is formed under the influence of the sun's UV radiation, right? That's where that word at the beginning, photo, comes from. So basically, you have volatile organic compounds plus some type of nitrogen and oxygen combination plus heat and sunlight yields ground level ozone and other photochemical oxidants. They also lead to aldehydes and other secondary pollutants that we spoke about, like sulfuric acid, for instance. So again, that's the difference between industrial and photochemical smog. Industrial fog is kind of formed right from the chemicals that we're releasing when we burn fossil fuels. Photochemical smog, you'll have what those chemicals that we're releasing, but you also need some sunlight to act on it, and then it produces a photochemical smog, which again is ozone and other oxidants, photochemical oxidants. So again, just understand the difference between industrial smog and photochemical smog, just in case you have to, write some of those differences in an FRQ. So, critical concept here, all right, factors that affect outdoor air pollution. What are the factors that can help reduce outdoor air pollution, right? These are the factors we want to concentrate on. Well, gravity allows particles to settle, so eventually, actually, the Earth's natural capital will actually clean out the atmosphere because gravity will allow those thicker particles to settle on down. Rain and snow actually acts to clean out the atmosphere, right? If it rains and it snows, it's like you're giving the atmosphere a bath, right? You're washing it out. Salty sea spray from the ocean can clean up the atmosphere. Wind can help dilute, right, chemicals and pollutants in the atmosphere. And actually, some natural chemical reactions remove some pollutants, right? So we talked about those secondary pollutants that actually form when primary pollutants react with nature. Well, there's some reactions that actually remove some of those pollutants. So the Earth's atmosphere actually helps itself, right? This is the natural capital. But as always, we're putting so much pollution into the atmosphere. The atmosphere doesn't have a chance to catch up, and that's why we're dealing with air pollution problems around the globe. What factors increase air pollution? Urban buildings, hills and mountains, those high temperatures, right, to combine to produce the photochemical smog, the volatile organic compound emissions from certain trees and plants, that grasshopper effect I talked about, which basically brings pollutants from warmer climates to colder climates, and that temperature inversion I talked about, right? Normally in the troposphere, we looked at the chart a couple of slides ago, temperature decreases with height, but in an inversion, it's actually colder at the surface than it is maybe a couple of 100 feet above the surface. So that is a very stable atmosphere. That's what happens in the Los Angeles area a lot, and that could keep right? It basically keeps the pollutants trapped near the surface, because if you have cold air at the surface, which is more dense, warm air aloft, which is less dense, you're basically, cold air continues to sink, warm air continues to rise, and you never mix out those chemicals that are below the inversion, or the pollutants that are below the inversion. So these temperature inversions can affect outdoor air pollution as well. And actually, here it is. I could have just changed the slide and kind of explained it to you. But again, in most cases, you have temperature decreasing with altitude, but in an inversion, the temperature increases slightly with altitude, which leads to a very stable layer, meaning you can't get mixing from the layer above and the layer below. So what happens is you have this inversion that sets up when you have cool. Like, this is LA's problem. You have mountains surrounding a cool ocean, the Pacific Ocean. So as that cool air comes in from the Pacific, it gets trapped below the mountains. And now you get all this pollutants that are trapped below the inversion layer. And that can lead to weeks and weeks of pollution. Have you ever heard of the June gloom? If you have friends in California, in LA and San Diego, they know the June gloom very well. Basically, you don't want to go to LA in June and July, because sometimes they get these inversions that set up for weeks, and the sun doesn't come out for a week or two, and all you have is pollution near the surface. And that happens a lot in June and July, because the water temperatures stay really cold, but inland it's very warm. And so when you mix that, you bring the cold air under because it's more dense, warm air is on top, and that's a stable atmosphere. Doesn't promote mixing, and so your pollutants just stay and get trapped. And you'll notice that's happening on the left-hand side here too. All right, so understand that major factor that increases your air pollution, these temperature inversions. Okay, moving on. What is acid deposition and why is it a problem? Well, acid deposition, what is deposition, right? The dropping or depositing. So acid deposition is the dropping or depositing of acid. And basically, we're going to be talking about acid rain. So acid deposition is caused mainly by coal burning power plants and motor vehicle emissions. They threaten human health, aquatic life, ecosystems, forests, and human-built structures like statues and bridges. So acid deposition, human generated, right? We have our nitrogen, some kind of oxygen combination there, and sulfur with some kind of oxygen combination there in the atmosphere. So this wet deposition is what we know as acidic rain, but there also could be acid snow or acid fog or an acid cloud, because if you have water droplets mixed with acid in a cloud, that is considered an acid cloud. Dry deposition is something called acidic particles, so we could just have particles that drop from the sky. And unfortunately, this acid stays in the atmosphere for 2 to 14 days. So once it's up there, it does remain for a couple of weeks. And that's why, again, we have this problem, and then the acid has to deposit itself somewhere. And so that's what we deal with acid deposition. So once again, looking at natural capital degradation, again, talking about acid rain. So again, we're looking at some of the ways that this acid gets into our sky, right? Nitric acid coming off of our cars, sulfur dioxide and nitrogen oxide coming in from our industrial plants. They get up into the sky and they form secondary pollutants, sulfuric acid and nitric acid, right? That then get blown in over somewhere where maybe it gets deposited as a dry acid deposition, but in most cases, the droplets are dissolved in rain or snow. Those are the droplets of sulfuric acid and nitric acid, and then that rain or snow falls to the ground as acid rain or acid snow, and obviously causes problems not only for forests, but for aquatic systems as well, as now the rainwater going into your lake has a pH that is less than 5.6, and so that messes up the pH and the aquatic system, what that lake happens to be. So here's the Earth, or the world, right? And you'll notice where we have potential problem areas for acid rain. Because of sensitive soil, potential problems because of air pollution, and then current problem areas. And you'll notice the Northeast is a major problem area, and that's because we have a lot of industrial plants in Ohio and in Pennsylvania, and the wind is mainly from the Southwest, so that blows those pollutants up into basically our area, New York State here. So especially north in the Adirondack Mountains, back in the 1980s and 90s, there were huge swaths of the Adirondack Mountains where all the trees had died, and that's because because of the acid rain. Now, again, because of that Clean Air Act in 1970, a lot of the pollutants in the air have been decreased, especially here in the U.S., so we're not seeing as much of a huge problem as we did maybe 30 or 40 years ago. But when I was your age, yeah, I mean, there were huge parts of the Adirondacks where all the trees were dead. All the lakes had a pH that was less than 5.6, or fish and things like that were dying because they couldn't live in it. Again, not so much of an area of an issue now, even though still problem areas, okay, across the East Coast here. Again, it is less because of the Clean Air Act and other acts that have helped clean up the air pollution. But again, major issue downwind of industrial areas is this acid deposition, which again, mainly in the form of acid rain or acid snow. So what does it do? Well, it contributes to respiratory disorders, this acid deposition. It releases toxic metals from soils and rocks, which allow for bioaccumulation in fish, right? Again, the toxins, the acid gets biomagnified as it goes through the food chain, lowers the pH in aquatic ecosystems, like I just told you, leaches soil nutrients, takes them away, damages forests, like I just told you, and damages statues and buildings, like I showed you that picture of that statue in Rome. So again, real problem with this acid rain. So how do we do it? Well, again, prevention is always less costly than cleanup. The real key here, guys, is let's use renewable energy sources, because if we can use those renewable energy sources, that will stop the impact of acid rain. So once again, acid deposition, prevention on the left, cleanup on the right. Just understand these, all right? Prevention, reduce coal use and burn only low sulfur coal. Use natural gas and renewable energy when you can. Remove, right, the sulfur dioxide and the nitrous oxide, or nitrous and nitrogen and oxygen types of gases from the smokestacks, and tax your sulfur dioxide emissions. Clean up, add lime to neutralize acidified lakes. Add phosphate fertilizer to neutralize acidified lakes. So these are ways that you can bring up the pH on any lakes where the pH has dropped below 5.6, or add lime to neutralize acidified soils, because again, if you're raining or snowing onto soil, you're actually adding to the acidity of that soil as well. So you can add some lime to help neutralize that soil. All right, so I'm going to stop there. This concludes part 1 of my lecture on chapter 19, air pollution and ozone depletion. Please make sure to watch part 2. And as always, thanks for listening.